Hey guys, BuildZoid here, and welcome to the HWbot score roundup number 18. We've got a lot of scores to look at again, so people have been very busy posting, some LN2 top scores and chilled top scores and all kinds of top scores. There's a lot of them. We got to get through them. That's the whole point of the HWbot score roundup, so let's get right into it. Starting off with Jiren 1388's 6-core GPU Pi for CPU 1 billion world record using a Ryzen 5 5600X at 6.024 gigahertz. So this is a really cool score because this is actually the highest clocked 5600X to ever run this benchmark. So in and of itself is impressive. And what's kind of wacky about this is what's kind of cool about this and wacky is how Jiren has managed to get this to work. Because the thing about Ryzen on liquid nitrogen is that the Infinity Fabric is not very happy at being cold, not very happy about being cold. And so we end up with these very wacky memory settings over here, which is 3000, DDR4 3000, 12, 15, 25, 50, 75, which is just like, my eyes hurt. This is painful to look at. Please stop. With a Northbridge clock of 750 megahertz, which means this is in desynchronized mode. So I'm assuming the Infinity Fabric is doing like potato speeds. Because the thing is, the whole memory system on Ryzen just gets so, it basically breaks once you're at really low temperatures. And you end up with things like this. But the thing is, the lower you can run the lower you can get the temperature of your 5600X or any Zen 2, Zen 3 CPU, the higher you can clock it. These chips are primarily limited by the temperature rather than the voltage. So if you can't get them as cold as possible, and this is actually true for a lot of architectures, but yeah, the priority is to get them as cold as possible. And that allows you to run the highest clocks. But, the memory system gets worse and worse. And so that's what Jiren seems to be doing here, is just giving up any hope at proper memory settings in order to get the chip to do 6.025 gigahertz, So yeah, and that's honestly really impressive because GPU Pi, it primarily cares about CPU clock way more than memory clock on the 5600X. So he managed to actually get the top score for 6-core GPU Pi by doing this. But yeah, those memory settings are terrible. There's really those are just bad. That's DDR4 3000 CL15, and then I don't know what is going on with the TRP. The TRAS is what on earth is that? TRC 75? What? And I'm assuming this is in gear down mode because there's no way, if this is what your timings look like, there's no way that's real 1T command rate. So yeah, but, GPU Pi doesn't care about memory settings. It cares about CPU clock, and Jiren really figured out how to, just max out that 5600X's CPU clock, so great job on that. And then, this is running on a Crosshair 8 Hero motherboard. Here's the setup. We've got some towels for insulation. Is he using a socket heater? I'm not entirely sure. Maybe not. Yeah. Though, the thing is, you'd expect the memory... Well, it might be from the start of the session, so that might explain why the memory is still not, totally frozen over. But, yeah, so here's the setup. That is a questionable... That power supply doesn't look very... compared to what you normally see on HWbot, where, basically everybody is running, 1,000-watt plus PSUs for, hey, maybe someday I'm going to run a 3-way setup, that looks like a very normal power supply. Did he mention... Oh, no, it's a 1,200-watt OCZ. Remember when OCZ was still around? They actually had a pretty decent 1250-watt power supply. It wasn't great. I actually had one of those. It it died on me when, I accidentally shorted out a fan header, and for some reason that killed the power supply, so that was great, but, yeah. They actually made an okay 1250-watt power supply, so I'm wrong. That's not a normal power supply. That's just a very old one. Because you get the colorful cables, and it's oh, so this is some sensible power supply. Nah, it's a 1250-watt monstrosity. Not that that really makes a difference with Ryzen's on LN2, especially a 6-core. It doesn't really pull that much power. But yeah, a very impressive overclock here out of that 5600X. Like, for comparison, actually I already opened that up, right? Like, there's Jiren's score with, 6.025, and we're going to go with 6.025 because I can only assume that his CPU ratio is actually 60.25. So this is just like the BCLK spread spectrum affecting the, or more like the BCLK floating around affecting the CPU frequency. And then we have Char at like 6,000, Safe Disk at under 6,000, Noms way below 6,000. Like, it is very hard to get 5600Xs to do, even 6 gigahertz. Like, the next 6 gigahertz run is all the way down here. So it is very hard to get 5600Xs to do 6 gigahertz on LN2 for 6-core GPU Pi. And Jiren actually managed to push, quite significantly past that, and so he now has the record for 6-core GPU Pi. And yeah, congratulations to him on that. And he also ran some Cinebench R20, because when you have a CPU that does over 6 gigahertz, well, you run all of it, like, you run as many CPU benchmarks as possible. Here he wasn't so successful. I think the sacrifices made to the made on the memory system and the Infinity Fabric are sort of pulling the score down, or it might be just down to how many times he's rerun the benchmark. Could also be to how much memory he has available. I don't think you shouldn't need max mem at these kinds of settings though, because the funny thing about Cinebench R20 is if you have a low max mem, it won't run, like, it'll run really badly. So you can't use like a super low max mem setting for Cinebench R20. And at the same time, Cinebench shouldn't really care that much about memory. So it's really surprising that actually Jiren didn't manage to take the first place here. So yeah, because he does have a CPU clock advantage over the 2 scores ahead of him, but the Infinity Fabric might actually be at this frequency, his Infinity Fabric might be clocked so low that it's actually dragging the Cinebench score down at this point. But still a very impressive score, and actually, again, the highest clocked 5600X to run Cinebench. So, in terms of the frequency he managed to hit for this benchmark, a very, very impressive result. And then still, 3rd place in Cinebench R20. This is a very popular benchmark, and the 5600X is a very popular CPU because it's not that expensive. So you have a lot of competition on LN2, and Ryzen chips are hard to run on liquid nitrogen. Like, they are very, very fiddly. Like, that's how you end up with memory settings that look like this. Like, they are very fiddly to run. And so, this is a very, very impressive score from Jiren here. So yeah, congratulations to Jiren 1388 on the Cinebench R20 6-core Cinebench R20 3rd place, and the 6-core GPU Pi for CPU 1 billion first place. Man, that is a horrible benchmark name. And let's move on to the next score, which is OGS's Geekbench 3 multi-core, 8-core Geekbench 3 top world record using the Core i9-11900K, doing 6.76 gigahertz. Producing a score of 65,848 points. Beating Senz's previous first place score, which was 65,514. Now, OGS, and actually we should just pull up the score from Senz because we're going to be using it for comparisons later. So OGS is supported by Asus and Crucial and Galax, and I believe here he's and OGS is a 2-man team, actually. It's not one person, it's 2 people. And I believe this is using Galax Hall of Fame memory. They've unfortunately not specified, which is very frustrating. Actually, no, Geekbench doesn't read out SPDs, and they didn't include an SPD readout because this is BDI, and Crucial does not make BDI, so, like, Crucial doesn't use Samsung BDI for their memory kits, whereas Galax makes Samsung BDI-based Hall of Fame kits. And so, the memory here, we're running like 5400 CL15, which is absolutely insane memory settings, with a TRFC of 280, which, yeah, at that kind of frequency, you're going to end up with a pretty loose TRFC potentially, on a Maximus 13 Apex. And yeah, the CPU is absolutely flying. 6.76 gigahertz is very, very high for Geekbench 3. The memory frequency also is just insane, right? Like this is at the limits of this is at the limits of what you can do in terms of frequency for Geekbench 3, right? Like Safe Disk was at 6.8, Ralph is at 6.68. Really not many people pushing these CPUs to even like most people sort of top out at around 6.7 gigahertz on these chips, if even that, right? Like we have a bunch of 6.5 and 6.6 scores down here. And so so the frequency, like just the CPU overclock here is already very impressive in and of itself. And then, of course, we have the absolutely ridiculous memory settings, which leads to a 13,154 point memory score, a 79,457 point floating point score, and a 78,586 integer score. Whereas Sen's, who was like the interest, so this is like so for comparison, so OGS is running 6.76 gigahertz, 5.4 gigahertz memory, 5.4 gigabits per second memory, and then CL15, whereas Sen's was running CL15, but at slightly lower memory clock, getting still basically the same memory score. 30 megahertz less like CPU clock, and actually more uncore frequency. And OGS actually has a really significant performance advantage on this integer test as well as the floating point test, and then a very minor advantage in memory. So yeah, that's really interesting. Because I guess the uncore frequency difference there isn't that important, and of course, like the CPU frequency is very important for the vast majority. There's not that many benchmarks where like your memory settings can save you, and even then, it's like Sen's is actually clocked lower on the memory, not by a huge margin, right? Like this is 2680 megahertz versus 2690, so that's like 10 megahertz or 20 megabits per second in terms of speed difference on the memory, but yeah, like, so a very, very impressive result from OGS, because that is actually, like, that is a very efficient score, to get first place by such a large margin, right? Because also you have Safe Disk running 6.8 on the CPU, but scoring like 300, like more than 300 point, like OGS is outscoring Safe Disk by like over 300 points. So yeah, a very, very impressive score from OGS in Geekbench 3, in 8-core Geekbench 3 with the 11900K. So congratulations to them on that. And let's move on to the next score, which is MLLR KLLR 88 Y-Cruncher Pi, 14-core Y-Cruncher Pi 1 billion. He's also known as Miller. So we're going to call him Miller for the rest of this, but yeah, so 10940X, because there's not really that many 14-core CPUs, which actually kind of makes me a fan of the 10940X, because the fact that, like, there's a few benchmark categories which are, like, permanently locked into these old CPUs. Like, for example, 5-core Cinebench, right? Because the only there was never actually a pentacore CPU. The only pentacore CPUs were 960T Black Editions, which are quad cores, but they can unlock to being pentacore CPUs. So an unlock 960T Black Edition is the only CPU eligible for the pentacore rankings, if I remember correctly, right? Yeah. Oh, and there's like some weird stuff down way down with like Athlons, but for the most part, it's basically just 960Ts. And so I'm kind of a fan of these, like, almost one CPU only type categories, because, well, they're just kind of neat, in my opinion. Because the competition in these, like, unlike, say, some of the other categories, you don't get a situation where like, say, quad-core, or actually, no, quad-core isn't really that, but, like, well, right now, 8-core, right? Like, the old king of the 8-core CPUs was, like, the 5960X, and then it was the, not the 6900K, because that was trash, but then it was, like, the 7820X, and then it was the 9900K, and now it's the 11900K, and so you get the idea, right? Like, where it's just like basically every time there's a new CPU, there's a new king of the category. Whereas there's these other categories like the 14-core chips, like the 5-core chips, like the 3-core chips, where, the competition is permanently stuck on the same CPUs. Which leads to some pretty interesting sort of like, you end up with some very heavily binned chips to sort of towards the top end. Whereas for a lot of the other categories, it's just like, oh, well, you just wait for the next release and there's going to be a whole new slew of top scores for that. So, yeah. So I kind of like the fact that the 14 cores are kind of rare. Though maybe we'll see more 14 cores in the future. That would be kind of cool. Though it's kind of an awkward core count, isn't it? Like 14 cores. Like, I like it because it's like, it's not quite at the time it was like, it doesn't cost as much as a 16 core, but gives you basically the same level of performance, because there's not that much difference between a 14 core and 16 core. But yeah, anyway, 10940X running Y-Cruncher Pi 1 billion, insanely hot benchmark, insanely power hungry benchmark, super heavy on the memory, super heavy on the CPU, literally. Like, the Y-Cruncher uses every square millimeter of your CPU and every transistor to the limit of what it can do. Ignoring PCIe. Like, mostly it just hammers the memory controller, uncore, and the core. You know, the important parts of the CPU. The parts not about like I/O and stuff. So this benchmark's just insane, and then on the X299 chips, it just gets that much more insane, because usually what limits Y-Cruncher is that you don't have enough memory bandwidth, but a 10940X is, of course, a quad-channel CPU. And it does have kind of a weaker memory controller than what you get on a lot of other modern Intel CPUs, as, you know, you're not really going to see these chips hitting much more than DDR4 4000, if even that, though here we're looking at 3840 megabits per second on the memory at CL12, which is basically like, that's pretty close to the limits of what you can do on X299, especially for a benchmark like Y-Cruncher, because Y-Cruncher is very, like, this is about as close as you get to having a stress test benchmark. It doesn't appreciate unstable memory settings. However, you can run MaxMem with it. You don't need, like, you can see here, 32 gigs of memory installed, because this is going to be 4 single-rank Samsung B-Die sticks. But the actual memory available in the operating system is just 6.3 gigabytes, because Miller is using MaxMem. And the reason you use MaxMem is when you're running high voltages into Samsung B-Die, it gets really unstable if you don't restrict how much memory is accessible. So with a 6.3 gigabyte MaxMem, you can still run Y-Cruncher at 3840, well, almost 3850 CL12. And then 5.1 gigahertz on the 10940X, and I'm pretty sure this is a sandbag, because I don't believe that chip is actually dragging itself all the way from minus 100 to plus 43 degrees. Or this chip has a really fiddly memory controller that doesn't work properly at low temperatures, which is possible, because the X299 memory controllers are fiddly. They're actually pretty fiddly at ambient, and they get more fiddly as they get colder. But the thing is like, because basically, I wouldn't be surprised if that chip was easily pushing like over 100 degrees Celsius delta between idle and load. As in, like, the chip could be idling at like minus 90, and then it would push itself all the way to plus 10 degrees Celsius. And a better example of that would be Miller's i9-9920X score here, where he actually hit 5.3 gigahertz. So he probably managed to cool the CPU down to lower temperatures, or this is a sandbag from like the beginning of the session when he was still at like higher temperatures. Or this chip has a weird memory controller that doesn't work properly as you approach the cold bug. That's still a very real possibility. It's an X299 CPU. Like, a lot of things that you can do at ambient suddenly don't work when you're at, you know, the limit, like right up against the limit of the temperature that these chips will tolerate, which is normally around minus 110 degrees Celsius. So, yeah, this might, like, but the thing is, it's still super weird to see the chip hitting 43 degrees Celsius. The 15 degrees Celsius, yeah, that's actually sort of like, yeah, that makes sense. That's Y-Cruncher. It's easily going to hit that. And so here we have a 9920X doing 5.3 gigahertz, similar memory settings. And, you know, the reason I bring up this score is because this is going to be pulling a similar amount of power. And so, like, this temperature, like this low temperature, makes quite a lot of sense. It doesn't make sense that 2 more cores would bring your temperature up another 30 degrees unless the temperature you were starting at was already pretty warm, which is, I think, is going on here And again, that could be for the memory controller, or Miller has a better score that was done at a lower temperature and he just hasn't posted it because, well, he's waiting for somebody else to try beat his score and then, post his better score again. And that's called sandbagging. And it is very, very common. And it wouldn't surprise me if that's what's going on here because, yeah, that is a weird load temperature for the chip unless the chip has like a very, very touchy memory controller for low temps. So, but still a very impressive score. And these chips are insanely hard to run on liquid nitrogen. Like, even before Y-Cruncher was like a thing at HWbot, these chips pulled these chips pull an insane amount of power. They actually like, what's interesting about these, even though these are soldered, they can still break the thermal paste because of just how insanely hot they are. So what you end up having to do with them is, like, if you're running a session on some of these, like, and X99 CPUs do this as well. So X99 and X299 chips, even though they're soldered, the solder's not, well, actually the solder itself can also fail, but that's really rare. But what tends to happen is as you're running a session, they'll actually start clocking worse and worse after like 30, 40 minutes or something. And the reason that happens is eventually the thermal paste just sort of stops doing its job. And you basically have to warm up to like minus 10 degrees Celsius and then pull them all the way back down to around minus 110. And that, the fact that you can't pull them all the way to full pot and you have to sit around minus 110 is a big part of why these chips are so hard to run, because you get them too cold, the fully integrated voltage regulator stops working. But they also pull an insane amount of power. So keeping them at like minus 110 degrees Celsius is very, very difficult because the temperature, like when you start a benchmark, especially something like Y-Cruncher, with good memory settings like this, the heat output of these chips is so high that like it is really hard to keep the temperature down to where you want it. And so, yeah, and by that I mean the temperature of the LN2 pod. I don't mean the actual temperature of the cores. That's a lost cause. Like this thing is going to, because ultimately you have the LN2 pod, then you have the layer of thermal paste, then there's the IHS, the layer of solder, and then we finally have the silicon. And then on the other side of the silicon, that's where all the transistors are. That's where your temperature, that's where your CPU temperature sensor is. So the crazy high temperature deltas that you get in something like Y-Cruncher, which, with the 10940X, this could easily be pulling in excess of 800 watts. Easy. Actually, I wouldn't be surprised if this was pulling over 1,000 watts, because Y-Cruncher is insane, and the X299 CPUs with their AVX512 acceleration make it just that much more insane. Seriously, this right here, is... it's basically a stress test that also prints out a score, which is nice. And doesn't take that long. And then, and then Miller also ran the 9920X, but here he only managed to get second place as Splave actually ran his 9920X all the way up to 5.4 gigahertz with basically the same memory settings. Yeah. Somehow managed to keep it much colder. So that's 1.4 volts, whereas Miller's all the way at 1.47. Yeah, that's got to be pulling like 1,000 watts. That's got to be, yeah. Honestly, these chips, like, if you're this is the kind of CPU where it's like, if you don't have a really powerful power supply, it'll just shut down your PSU. Which is not, like, there are GPUs that can shut down power supplies. But it's very rare that there's CPUs that have, like, problems with shutting down power supplies. X299 is one of the few platforms that does that, and I guess Threadrippers as well. And then there's also the W3175X, but, that's a very silly CPU. That's like X299, but bigger. So yeah, congratulations to Miller on the absolutely just ridiculous 10940X Y-Cruncher 14-core Y-Cruncher run with any Y-Cruncher run is ridiculous. Like, seriously, this benchmark just takes, because that's the thing is, like, oh, you might be looking at this like, that's a rather low frequency. Yeah, it would be if this wasn't Y-Cruncher. So Y Cruncher is just a ridiculous benchmark, which by extension means any run of Y Cruncher is ridiculous. But congratulations to Miller on the 14-core Y Cruncher Pi 1 billion first place, and also the second place in 12-core Y Cruncher Pi 1 billion. And let's move on to the next score, which is Dominator's 3D Mark 11 Performance, 4th place, using a RX 6900 XT. So the 6900 XT is the GPU of 2021, which is truly, ideal for DirectX 11 benchmarks. It's kind of true, though. Like, 3D Mark 11 is from, I believe, 2011, and it's designed with DirectX 11. Anyway, so the 6900 XT is really good at these old 3D, old DirectX 11 benchmarks, partially because you can disable tessellation for them, partially because it's just really good at these old, lower resolution benchmarks. And 3D Mark 11 is definitely one of those, but the 6900 XT is a little bit too good at 3D Mark 11, as it ends up extremely CPU bottlenecked unless you run it with something like an 11900K at like almost 6.6 gigahertz, which is exactly what Dominator has done here. And also he's using a RX 6900 XT Extreme Edition. So that's the XT, so that's the XTK. So that's the unlocked card with the extra voltage and, higher higher clock limits. And it's the toxic version from Sapphire. So that comes with the AIO water cooler. And he's running this on a Maximus 13 Apex, and yeah, 11900K doing 6.6 gigahertz because this GPU running 3D Mark 11 hits like 544 FPS in graphics test 3, and that's average FPS. That's not max FPS, that's average. So when you're hitting this frame rates this high, you end up very CPU bottlenecked. And actually, I think it's GT1 and 2 that are more hard on the CPU, if I remember correctly. 3D Mark 11 is not a benchmark I run very much because I really suck at the physics score on it. And speaking of the physics score, it's actually pretty heavy CPU benchmark. It's also pretty stressful on the memory and cares a lot about your memory settings. It's a pretty good memory benchmark because of that. And then you also have the combined score, which is a mix of CPU and GPU load. And the combined score also just kind of prefers having a really high clocked, relatively low core count CPU, though the benchmark does scale up to like 32 threads. So I think the record for it is currently held by a 5950X, or actually no, a 10900K, because the fun thing you can do with you just have more threads with a 10900K. And that physics simulation does scale up to 32 threads. There's fun, with it's 3D Mark Vantage, where with the 10900K you can run 10 cores, 16 threads, but you don't need to do that for 11. 11 goes up to 32 threads. So, you can just run a 10 core, 20 thread 10900K, and at 6.9 gigahertz, that kind of chip will have plenty of single threaded performance to, support the 6900 XT. It's not really carrying it. Like the issue here is the 6900 XT is like very much too fast for a benchmark like this at this point. And so, yeah, congratulations to Dominator for managing to push 4th place. And I believe he's actually working on some LN2 scores with that 6900 XT. He has posted some LN2 scores with the 6900 XT, but I think so far this has been his best result, and that's just with the CPU on LN2. So it'll be interesting to see if he doesn't rerun this with both the CPU and GPU on LN2, because like some of those GPU tests, like they're not that high FPS that they couldn't be higher, right? So yeah, congratulations to Dominator on the 3D Mark 11 single GPU performance score, 4th place. And let's move on to the next score, which is Antoine 06's Y-Cruncher Pi, 6-core Y-Cruncher Pi 1 billion. And we all know, like, I love Y-Cruncher. It's such a ridiculous benchmark. On a second place on a Core i5 11600K. And I think he was second, and then, or actually, no, was he third? Because I remember featuring Antoine with an 11600K in Y-Cruncher before. Actually, we could just check the history of his 11600K. We go to hardware library, 11600K. So his old Y-Cruncher 3233191. Oh, so he was already in second place, and now he's just more in second place, as he has improved even further on his previous top score. 11600K on chilled water cooling, doing 5.1 gigahertz, using a Gigabyte Z590 Aorus master motherboard, memory hitting 4533 megabits per second, 15151528, dual rank Samsung B-Die from G-Skill, Trident ZRGB sticks, not that that really matters that much, because I don't think you can really... Like, maybe if you looked for a really, really old kit, you could get, like, a dual rank stick that uses an A0 style PCB. And by A0 style, I don't mean actual A0. It would be B0, if I remember correctly. Fun fact, B1 actually uses the same chip layout as A2. Because the dual rank PCBs were kind of more important to fix the, like, improve the, the signal. I think it's mostly a signal integrity optimization. That's the difference between A0 and A2, but it might also be a timing thing, because like DDR is like the way memory works is, well, actually we'll not get into that. So I'm not sure on the specifics of it, but basically the equivalent of A2 is B1, and A0 and B0 I think are the same thing. So it's just kind of weird how dual rank actually uses a layout that's more similar to a later revision of the single rank PCBs, and it came actually before. Like it came, I think it came out earlier, because there is an A1 PCB, but that's designed for like ECC memory setups. Anyway, yeah. So what makes this score cool, of course, is that this is an 11600K that's in second place for 6-core Y-Cruncher, and the reason this is possible is the 11600K has AVX512 support, which Y-Cruncher takes full advantage of. And also, with only 6 cores, this isn't insanely memory bottlenecked by the dual-channel memory controller. And so with a dual-rank Samsung B-Die kit running, 4533 CL15, you have enough memory bandwidth to feed all of those cores running AVX512 instructions. The side effect of that is that this runs insanely hot. Of course it does. And so this is a really impressive score, because this is just like this is, competing with like LN2 scores, if I remember correctly. Yeah, like this is straight up beating, like the only score that's faster is clocked like 1.1 gigahertz higher and on LN2. And then everything else that has ever run Y-Cruncher is actually slower than Antoine's chilled water cooling setup with the 11600K, because he really dialed in those memory settings for this benchmark. And there's also a bunch of like runtime options that you can tweak for Y-Cruncher, which makes it a bit different from a lot of other benchmarks. But I don't believe, like, the thing is, they're primarily meant to help optimize for things like Threadrippers and X299 CPUs, like CPUs which don't have necessarily very symmetrical memory layouts, which 11600Ks aren't really. They're very, like, 11600Ks are relatively simple chips. So yeah, I can't imagine that like, well, it might be part of it here, but yeah, I don't know. But what I know for sure is Y-Cruncher loves memory. It loves memory, and it sets your CPU on fire, and that makes this score really cool, because you need to to get into to get an 11600K to the very top of these rankings, right? Like it is still it is second place on just chilled water cooling is just a crazy achievement. So yeah, congratulations to Antoine06 on the 6-core Y-Cruncher Pi 1 billion score with the 11600K. And let's move on to the next score, which is Salty Croissant's 3D Mark Firestrike on the GTX 690. So I've featured Salty Croissant with the GTX 690 in, I believe, the previous roundup. And since then, I think I either said it in the video or I told him in Discord chat somewhere. I told him, add caps. You need more caps. And so he added caps. I don't think this is enough caps. It's a 690. It needs more caps. Like, I've had a GTX 680, which I think kept improving with extra capacitors all the way up to like 20,000 microfarads. So this right here, not enough caps. More caps. But let's go through the history of the 690 when it comes to running Firestrike, because it is quite an impressive improvement that Salty Croissant has gotten out of it, because he was already first for 3D Mark Firestrike on the GTX 690, and he wasn't satisfied because previously this card was kind of running, nope, hardware library. Yeah, previously this card, and he has a lot of cards. He's been very busy benching these cards. Previously, this card was running Firestrike at 1332. Which, in the grand scheme of Kepler GPUs just isn't very impressive because it's not very impressive. Realistically, if you have like a good GTX 680, you would want to be hitting like 1400 plus on the core, or like 1400-ish on the core. So hitting 1332 on chilled water cooling, not acceptable whatsoever. But the thing is, you can get GTX 680s with properly designed custom PCBs instead of this joke that NVIDIA ships out. Which instead of power planes has power strips because the VRM is literally sideways relative to the thing it's trying to power. So you can probably, in terms of what that does to the impedance of the power plane, probably not great, right? Like usually you want your power plane to be very wide and very short. Whereas NVIDIA's power plane is the exact opposite of that. It's very long and very skinny. And so naturally, and then also it's just an NVIDIA reference card, so of course it's not going to have enough capacitance to begin with. And so, Salty Croissant basically just threw a bunch of extra capacitors on there, and the card went from running 1332 on the core, this is still the same chiller. I imagine he's still running the same amount of voltage or similar amounts of voltage, because previously he was complaining that it wasn't properly scaling with voltage, and I basically told him, yeah, it's probably because it's the filtering's terrible, which means that sure, your average voltage goes up a lot when you raise the voltage, but your minimums are not necessarily going to go up as much, because as your transient loading increases due to the higher average voltage, your undershoot can actually still be really, your undershoot isn't necessarily going to get pulled up as much as you'd like it to be, because there's not enough capacitance, and what capacitance there is relatively far away from the thing it's actually trying to, filter, which is the actual GPU cores, not so much the VRM. Like the VRM, honestly, I'm not even a fan of the way these capacitors are laid out here, which I maybe should have told him when he first posted this picture of his card, that but anyway, too late. It gives us something to talk about. Basically, all of these capacitors should be here, here. And I'd run like a power bridge. I'd try to put a power bridge on this, and I'd really try to put the capacitors towards the core rather than over here. Because especially considering the fact that this isn't so much a power plane as it is a power strip, you don't want to be adding the impedance of the power plane to the impedance of the capacitors. Like, the capacitors have enough impedance as is. Put them as close to the core as possible. That wouldn't necessarily make that much of a difference, but it could help. And then also I would just use more capacitors. This is just not enough. Just more. He's already committed to putting capacitors, capacitors with legs onto multi-layer ceramics, which I'm personally not a fan of, because if you do this and then you hit the card by accident or something, it's very easy to just rip the end caps off of the multi-layer ceramics. So I don't like putting through-hole capacitors onto multi-layer ceramics like this, but if you're already doing that, commit to it. You've got 4 more capacitors, you've got a bunch of multi-layer ceramics, you've got 3 more multi-layer ceramics over here. If this was my card and I was actually committed to doing this like that, there'd be 6 more through-hole caps behind each core. Not exactly where you'd want the through-hole capacitors because they're relatively high impedance, but, they'd be there anyway. And if you've got any dead cards lying around, you can actually just desolder the multi-layer ceramics off of... Well, that's kind of fiddly if you don't have hot air. But if you have hot air, and you have dead cards lying around, especially high-end dead AMD GPUs, just desolder all the capacitors behind the core. A lot of the time, you will get 47 microfarad multi-layer ceramics there. And then just whack them behind the core of this thing for further improvements in overclocking. So, yeah, this is really cool to see that a cap mod worked for somebody else than me this well. Actually, I think he has more success with this than I think most of the cards. The problem is I usually don't buy trash NVIDIA PCBs, with the exception of the GTX 590. Um, but yeah, so on with this GTX 690, like that's a really big improvement from just adding capacitors. But does it surprise me? Not really. It's a NVIDIA reference design. Like, what did you expect? Actual build, like proper quality? There's also a decent chance that the capacitors that are already on the card were pretty like aged, as these SMD polymer capacitors like this, they don't come in high endurance ratings in my experience. Like the molded capacitors, you can basically only get them in like 2000 hours at 105 degrees Celsius, which isn't a totally terrible endurance rating, but it's not high. Like a high endurance capacitor would be like 10,000 hours at 105 degrees, but they don't make that for molded polymers as far as I'm aware. And then this is also a 690, so this thing runs really freaking hot because the cooling system is barely up to deal. It runs really freaking hot, but NVIDIA will assure you that it's in spec, which it technically is. At stock, it probably runs it still runs just fine at stock. It just overclocks like trash. And that might be a combination of just like, well, the power delivery is just, well, terrible. And then also the caps might be pretty aged by the fact that they're on a hot running card, and that card is quite old. 690s aren't exactly new. So, yeah. But still, it's really great to see somebody get so much gain out of like, and I don't even like, this is not that crazy a cap mod. And I think he's salvaging a lot of these because there's a mismatch. Like this is 330 and there's a 470, so these look like salvaged capacitors. Wait, if you're salvaging molded polymers, just pull MLCCs as well. Yeah, like if you're salvaging these, salvage multi-layer ceramics and then pop those over there, and then more through-hole capacitors, just more. Just keep adding them until the clocks stop going up. And that is actually a method I've used in the past. Actually, that's a method I still use. It's like if basically until the oscilloscope says that we're at like 100 millivolts peak to peak, add more caps. Which if you don't have the oscilloscope, just keep adding caps until it stops improving. Keep in mind that every time you add a round of capacitors, the next round might have to have a bit more might have to have more capacitance in order to still make a difference. And anyway, yeah, card on chilled water cooling. Like Salty Croissant's been in these roundups very, very frequently, so I'm sure we're all familiar with his chilled water cooling setup and his very good 5900X, though here it's kind of running a bit relaxed at just 4.7 gigahertz. Yeah, that's kind of relaxed for his chip. His chip does 4.7 at what like my chip needs for 4.6. Actually, no, I think I can do 4.65 at around that voltage. Yeah, like this is, I think he currently actually has the highest clock GTX 690 on HWbot. Because all of these have trash PCBs. Like you're not gonna get a custom PCB GTX 690 because NVIDIA didn't allow their board partners to design a proper GTX 690. So the only version of a 690 you can buy is a, NVIDIA reference design, which is trash, because of course it is. And so consequently, Salty Croissant is the only one to even approach 1400 core, because, well, everybody has to deal with the same power delivery issues. And this card right here looks really good, considering it's just on water cooling. We also don't have a proper screenshot for this score. Interesting. Wait a minute, that might not actually be hitting 1346. Yeah, wait, no. Oh, wait. Okay. Average clock 1358. Right, because boost. Anyway, like either way, Salty Croissant does currently have the highest clocked GTX 690 on HWbot. And those caps certainly did a lot for that, because previously it was only doing 1332. So that's like almost a 40 megahertz improvement right there. So that's cool. And congratulations to Salty Croissant on the improvement there. And let's move on to the next score, which is BullAnt's 3D Mark 05. And I don't know what is going on here. Like, this is Windows 8.1 Pro. Apparently, this is the optimal 3D Mark 05 operating system, because 3D Mark 05 is one of those old benchmarks that I don't know very much about. And BullAnt actually knows a lot about. He also has, like, I think he currently has the world record for 3D Mark 03. Okay, no, just 3D Mark 03 triple GPU, second place. And 3D Mark 2001 SE, world record, yeah. Okay, so I misremembered. It's 2001, not 03. But either way, BullAnt knows what he's doing when it comes to these old 3D marks, starting with 0 something. Ending in 0 something. And so here we have a GTX 680 doing 1400 megahertz core, which is what you'd expect from a good air-cooled GTX 680, and 1800 megahertz memory, which again, like a good GTX 680 should do that. And then an 11900K with 5 cores and 5 threads enabled, because this is an old benchmark. It doesn't know what a hyperthread is. Actually, it probably, like, the thing is, the way hyperthreading works, the benchmark doesn't need to know what a hyperthread is, but it doesn't know what core 8 is. So you don't need 8 cores. And you also don't need, more than 5 threads. And so 5 cores, 5 threads, 6.7 gigahertz, with 4400 CL15 on the memory. So Samsung B-Die again, running on a Z590 AOS Tachyon, and beating Dominator by 3,000 points. And the reason that is really interesting is that Dominator over here was actually running 3 cores, 3 threads at 6.9 gigahertz on his 11900K, with weaker memory settings, because that is 4266 CL19 on a Maximus 13 Apex. And BullAnt is just, like, beating him by 3,000 points. Is it entirely down to... Actually, and also, like, this is super annoying with these screenshots sometimes. If we zoom in on the FPS down in the corner, right? Return to ProxyCon, 319 FPS. Firefly Forest, 247 FPS, and Canyon Flight, 595 FPS. And this is, on a 1500 core GTX 680, right? 1500 core, 1800 memory. So the card is clocked higher, the CPU is clocked higher. And then BullAnt is over here doing 332 FPS on Return of ProxyCon, so that's at like 20 FPS advantage. Okay, no, more like 14 FPS advantage. Yeah. And 263 FPS on Firefly Forest, which again is just more FPS than Dominator. And then Canyon Flight is also, and Canyon Flight's actually slower for BullAnt. So, yeah, very interesting, because, the CPU's clocked lower. The memory settings are a lot better, so that might be most of it. Or it's the core configuration, or it's the OS. It's probably a combination of the things. But yeah, BullAnt really knows what he's doing when it comes to these old 3D marks, and I have no idea what's going on here, because, like, his clocks are lower, except for the memory. Like, his memory is significantly, like, yeah, that's significantly better settings. Like, that's higher frequency and lower timing, so this is JDEC TRFC over here. This looks like I'm guessing Dominator just enabled XMP for this. That really does look like he just turned on XMP. So BullAnt over here, like, is it really all memory? That would be really surprising to me. I mean, it's not impossible that it's all memory, but really? Is this our new one true memory benchmark, 3D Mark 05? I kind of doubt it. Like, and then also the fact that this is Windows 8.1. Like, I've never even installed a Windows 8.1. So, yeah, this is a score that is just, like, crazy efficient, right? Like, less frequency on the CPU, less frequency on the GPU, more FPS. And I wish I could tell you why. I think it's probably the memory settings. But then I'm also confused about as to why you would run this on Windows 8.1 of all things. Because, yeah, I don't know. So, I don't know what's going on here, but I am impressed by that. Like, that's a significant gap, right? Like, 93,000 points versus 90,000 points. That is not a small performance advantage there. So, congratulations to BullAnt on taking the first place in 3D Mark 05 with a GTX 680. Let's move on to the next score, which is White Shark and his 3D Mark TimeSpy Extreme first place on a GTX 970, doing 1900 megahertz core and over 2 gigahertz memory. And 900 series on LN2 is awesome. Recently I finally got around to running a Maxwell card on LN2. Also, did he plasti dip his card pink? Or what is going on with that? Like, it is pink, right? It's not like, maybe it's red, but really thin. Or maybe it is actually a pink card. Original color choice there. But anyway, and he's also using a backplate heater. So that's the Elmore Hot. I think it's the Elmore Hot. Yes. So it has a board heater for the card. So this is just to prevent condensation building up on the like memory. Well, on some cards you need it to keep the memory chips happy, because if the memory chips get too cold, they get very upset. And on some cards, it's just like it reduces how much condensation you have to deal with, which can potentially extend your session. And then there's some cards where you actually want the memory chips cold, in which case you don't want to be using a backplate heater at all because you need the memory chips cold. Though those are kind of rare. I think GDDR5X cards fall into that category of like they actually go faster if the memory chips are frozen. But this is a GTX 970, so this does not use GDDR5X. This uses regular GDDR5. And the thing is, like, I ran a Titan. I did not run a 970, but I would assume 970s behave pretty similarly where, like, they just scale to insane voltages. And you hit some very, very high, and you get to hit some very high clocks. So at least, at the time, this was a high frequency. These days, we're used to GPUs doing 3 gigahertz, but back then, 1900 megahertz was very, very high. And so, yeah, White Shark has taken the first place in TimeSpy Extreme on the GTX 970 by a, pretty significant margin. Actually, that's much less of a margin than I thought it would be. I guess because he's going up against... Wait a minute. What's going on? So the GTX 970 famously doesn't actually have 4 gigs of VRAM. Not properly anyway. There's like this weird awkward thing with the memory controller where you own like the last half a gigabyte of memory is only accessible at like what is it? 1/8 the usual 1/8 the usual bandwidth because of how the memory controller is set up. Does TimeSpy Extreme use too much RAM? Because that is actually a possibility. Like there are a few 3D marks where it's like if you don't have X amount of VRAM, you're just screwed. And so the fact that this card doing 1900 megahertz core, which is a really, really high frequency, is barely pushing out more FPS, really makes me think it's memory bottlenecked, isn't it? Like it's gotta be. Either way, White Shark did manage to clock the card high enough that he just kind of beat everybody else, even though it really does look like he is limited. Like, I'm assuming this is memory limited. It's a real shame there's no 8 gig GTX 970s. Actually, it's a good thing. There's the fun fact that for GTX 680s, Firestrike Ultra requires 4 gigs of VRAM to run properly. So a regular GTX 680 can't run Firestrike properly, which is fun fact. I mean Firestrike Ultra properly, because Firestrike Ultra is a 4K benchmark and requires a ton of VRAM. But so I'm guessing TimeSpy Extreme might be a similar situation because you'd really expect a card clocked this freaking high to be like significantly outperforming a card that's like doing less than 1600 on the core. So that is interesting. Odd choice of benchmark to run on a LN2 GTX 970, though. I think White Shark might just be trying to get every single GTX 970 top score. Or not. It's Time Spy Extreme. It's Bullshooters. Very odd choice to run Time Spy Extreme there. Still, a really impressive GPU clock. Weird benchmark. I've never run Time Spy Extreme. I should look into that. Like, how much because, yeah, that should be very easy to check how much VRAM it needs. Because there's a chance that the 970 just can't run it properly. Anyway, yeah, so still though, like, White Shark managed to get to first place, and he did it with LN2 on both the CPU and GPU, though the CPU's kind of relaxed here, right, at just 4.6 gigahertz. I mean, it's producing enough of a CPU score that it doesn't really matter. Yeah, so let's move on to the next score in this week's roundup, which is Isonzo's 3D Mark Cloudgate on a 3D Mark Cloudgate second place on the GTX 780 at 1420 core and 1954 on the memory, which is really high for the memory clock, and his screenshot doesn't show that really high memory clock, so I'm not entirely sure what's going on there. But the core clock actually is also really, really good. Like, being able to run over 1400 megahertz on a GTX 780, like, that is a that's great actually. Because the big Kepler, like I said, for 680s you want to hit around 1400, but for the big Kepler chips, like, they pull a lot more power and they clock quite a bit lower as a result of that, because they're just so damn big and power hungry. And so this card's on chilled water cooling. Very strong chilled water cooling, considering the 5950X is apparently sitting at 31 degrees Celsius load. And the GPU, man, he's got to be mashing voltage into that thing for it to be hitting 30 degrees Celsius. Or that chiller's not as strong as I thought in the 15... Nah, that doesn't make... Or that is idle temperature for the 5950X. Yeah, something doesn't add up. Like, or I've never run the physics test in this, so I actually don't know how heavy that physics test is, but... Do we seriously not have a temperature readout for the CPU? We don't. Okay, well, that's a shame. Still, like, hitting over 1400 core on a 700 series card, like on a 780 or a 780 Ti, is just generally hard. Like, JK110s are hard to push that far. And so that alone already makes this score very impressive. Then I don't know what's going on with the memory clock, but, you know, the score is still, like, he has like, his screenshot is correct, so I'm not going to worry about, like, maybe this is a leftover from a different score. Yeah, and then we have the 5950X doing 4.75 gigahertz, which is actually, you know, pretty important here, because the GPU score is very, very high compared to the physics score. And if we look at the first place score, I can't imagine that's anything other than a 5950X as well. Actually, that's a 9900K with 25,000 points in the physics test. This physics test, it might be worth it to try run this with just 16 threads instead of 32. Though I don't know. Like, I've never, like, I've not benched Cloudgate. I have run it. I've not benched it. There's a big difference between the two. When you run it, you don't care about the score. When you bench it, the score is the number one priority. And so Char actually has I guess the 400 plus FPS during the actual benchmark is probably pretty upset about being on a 5950X instead of, like, a almost 6 gigahertz 9900K. So that, but still, like, you know, 1450, like, that kind of frequency from the 780 there is very, very impressive. And of course, dry ice is going to push the card even further. But yeah, great, like, congratulations to Isonzo on pushing the GTX 780, like, pushing that GTX 780 to second place in 3D Mark Cloudgate. And let's move on to the next score, which is Ice Bear's W Prime 32 million on quad core W prime 32 million. Well, actually, no, it's W prime 32 million specifically on an i7 900 and 930, doing 5.15 gigahertz. Unfortunately, I do have awful lot of X58 motherboards, but I don't have an awful lot of experience overclocking X58 CPUs. But i7 930s, very cheap. Apparently, well, consequently rather competitive, and apparently very hard to work with. Oh boy. Yeah, very hard to, or really inconsistent in silicon quality. As we do have some chips running, yeah, I guess they're kind of all over the place in terms of chip quality, aren't they? Anyway, yeah, so Icebear managed to push his i7 930 all the way to 5.15 gigahertz, getting him to 5th place in the i7 930 rankings with a runtime of 4 seconds, 656 milliseconds. And you know, this is a very popular CPU. It's old, it's cheap. So there's a lot of competition. Not necessarily on liquid nitrogen, but considering that there's a Cascade, actually that's Icebear's Cascade. I wonder if we'll see him run on LN2. Maybe there's more headroom left in that chip, or maybe that Cascade. Actually, that is a really strong, that's a strong Cascade. That goes down to minus 80. That's impressive. So maybe that chip is pretty close to maxed out as is. Also, what a very clean insulation job there. I'm pretty sure this is done with a syringe, the top side, and then on the back, you can clearly tell that's a paintbrush right there. That is very much a paintbrush. So I don't normally bother with the CPU socket cavity because you can just put if you just ram some blue shop towel up against that, between the mounting bracket for your LN2 pot and the back of the socket, you're not going to get condensation in the cavity if you do that. So I don't normally bother with the center part of the CPU socket, but everything else, yep, this is really clean. I normally go with actual fills, not specific inductor legs. Though I guess if you're ever planning to do any kind of modifications, this would be a lot easier to partially peel off just the parts you want to fiddle with. If you need to do a repair or a modification, you can just peel off the small bits of it instead of having to peel off a lot of it. So a very clean insulation job there. All the DIMM slots covered. You don't really have to do anything in that area anyway, ever. And then on the top side, we've got, I have to assume this is done with a syringe, especially going between the DIMM slots. You usually, a syringe is super useful for that. So, yeah, clean insulation job, solid Cascade right there, and postcode card. So, for these older motherboards, you should probably, very good idea to get one of those for the older motherboards. And with old motherboards, you at least have a PCI slot, so you don't have to find a PCIe postcode card. You can just get a PCI one, which the PCI ones are way more common and easier to find. And then W Prime 32M is one of those wacky old benchmarks that runs best on Windows XP. But luckily, if you're on an i7 930, Windows XP just kind of works on that just fine, right? That's an old enough architecture that's not really going to be a problem. And this is a benchmark that is basically all about CPU speed, just raw CPU frequency, doesn't really care about memory at all. Even though Icebear is evidently running, he might have been running some other benchmarks as well, because these memory settings over here aren't exactly, they're not slow. They're not insane, though. And then the other thing is there's a lot of software optimizations you can do to get W Prime to run faster. Don't ask me about those. I don't know. I don't run W Prime that seriously. I like it because it's short, not because there's a bunch of stuff to do to make it run faster. So yeah, so congratulations to Icebear on pushing the i7 930 to 5th place. I'm assuming this is some kind of pre-testing, because I remember Icebear also posting LN2 scores that made it into past roundups, if I remember correctly. So we might see this i7 930 do more, or maybe this is yeah, we'll see this i7 930 do more in the future. Either way, a solid result for the i7 930 here, and so congratulations to Icebear on that. And let's move on to the next score, which is TrueMonkey's 3D Mark CloudGate first place using a GeForce GTX 275, running 770 core, 1330 on the memory. Is this pre-GDDR5? Yes, this is a GDDR3 card. So I don't know what that means, actually, now that I think about it. Yeah, I'm not actually sure. I don't. This falls well into the category of GPUs that are too old for me to find them interesting. It's like if it's pre-GDDR5, I'm not interested. And so or I'm not interested in trying to run it myself. Anyway, here we have CloudGate run with a 5950X, of course, the perfect CPU for your GTX 275. 5950X doing 5.16 gigahertz, so that's on a single stage phase change, of course. So that's probably somewhere around minus 50 degrees Celsius at idle. Load temperatures are potentially going to be much, much higher than that. 3800, 14, 16, 16 on the memory, so pretty relaxed memory settings. Then again, I'm assuming CloudGate doesn't really, like the physics score there looks fine, so I'm assuming it may very well not be that sensitive to memory settings. And then, top score for the GTX 275. I wish I could tell you more about this card, but I mean, he is running pretty high clocks for a GTX 275 if you look at all the different submissions for CloudGate. This is actually a super weird one because CloudGate is like a very modern benchmark and the GTX 275 is a very old graphics card. So it's really surprising to see this many people run this very modern benchmark on this really old GPU. But yeah, of the people who have decided to run this like weird combination of GPU benchmark and CPU in many cases, because, well, this is done with also a 5950X, because of course it is. Then we have Nick, who's running a 7900X, right? So TrueMonkey's not the first to have the idea of running a way too modern CPU with that 275. But he's also the one to actually push the 275 the furthest, along with the overly modern CPU. As there is one card that was pushed a little higher, but the thing is, CloudGate seems to be exhibiting the typical 3D Mark Vantage behavior of like the only thing that if your CPU is fast enough, the only thing that matters is the physics score. How's TrueMonkey doing on GPU score? Yeah, because Plasma Carrot here, with the slightly higher core clock and lower memory clock, actually has a GPU score advantage. That, I imagine you could also do a bunch of like... Is this score valid? Graphics driver is not approved. Because I would assume, like, with a 275, you should be able to do, like, LOD. Change the level of detail to get some more performance out of the benchmark as well. Yeah, so this is also running LOD, so that could actually be a big part of that slightly higher GPU score. Though I don't know how heavily CloudGate is affected by the LOD tweak. Either way, congratulations to TrueMonkey on being the fastest person to run a GTX 275 in 3D Mark CloudGate. Which apparently, like, there is actually quite a few people who think that that is a good benchmark to run on this ancient GPU. By my standards. Again, like, if it's GDDR3, it's too old for me. So, yeah, and that brings us to our last score for this week's roundup, which is Skull's SuperPi 32 million on a Pentium G860 at 3.208 gigahertz. Which is not a very high frequency, but that's because this CPU comes with a 30x ratio, and it's locked because it's a Sandy bridge. And because it's a Sandy bridge, it also can't overclock the BCLK that much. So at 107 megahertz BCLK, memory, actually impressive settings. I would have thought a Pentium's memory controller wouldn't be able to do anything. Well, it's not that great, but it's not terrible. What is that? That's like 2280, 811.7. Okay, so the thing is, Sandy Bridge's memory controller is not its strong point. partially because of the like really low BCLK limit and the fact that Sandy Bridge also has an extremely low max memory ratio. If I remember correctly, you can't go over 2133. So if you want to run high frequencies, you have to use the 2133 ratio and then, max out the BCLK for that. But the other thing is, like, even at 2133 and these lower memory, like these lower DDR3 clocks, it's just not that great at it. For Sandy Bridge, this is actually like, solid memory settings right there. And then 106 megahertz BCLK is quite hard in G860. The real thing here is the commitment to running this benchmark for 10 minutes. Though I imagine it's not too difficult when, you are running it on a G860 water cooling setup. That's the most overcooked. Actually, no, I'm sure somebody ran this on a phase change because that's the HWbot standard. Like you run your potato CPU on single stage phase change. So this is not actually like this looks really overkill if you like by normal standards. By HWbot standards, it's not overkill until you take one of these on liquid nitrogen, which is probably completely pointless because it is a sandy bridge, and sandy bridges generally have a very warm cold bug, so you'd probably be wasting your liquid nitrogen doing that. But that's the advantages of single stage phase change there. Anyway, so Skull managed to push this to second place, and there's a surprising amount of competition for the G860 because, well, there's actually a surprising amount of competition for a lot of these old locked Sandy Bridge CPUs and Ivy Bridge CPUs because, well, they're cheap, and they basically, like, especially if you're running a benchmark like SuperPi 32M, it just becomes a there's a bunch of tweaking you can do to get SuperPi to run faster. Things like the olive green Windows XP theme, that's actually a thing for whatever reason. SuperPi 32 million runs faster if you use the olive green theme. Or so I've been told. I've never verified this myself, but everybody does it, so probably works. And then there's other things like CopyWaza, which is which basically just copy pastes a bunch of files around, a bunch of small files around, and then the benchmark runs faster. Why? Don't ask me. And so because of that, a lot of these locked CPUs, like the thing is they're cheap. You can sort of flex your memory overclocking skills on them. Not like it's a Sandy Bridge, so not really, but like I guess there is a sort of uniqueness factor to like running, like messing around with memory on these locked Sandy Bridge CPUs that like it's just going to be different behavior compared to what you're used to. And then then you run a benchmark like SuperPi, and you have all the software stuff that you can fiddle around with to try get the best possible SuperPi score. So, yeah, that's sort of why we have a lot, like why there's so much competition on a lot of these locked CPUs in benchmarks like SuperPi, because like you can see it right here, right? Skull is actually clocked a little bit lower than Tomek Mac, and outscoring him by quite a significant margin. And I'd assume that's mostly memory settings, right? Actually, no. It looks like, well, oh no, wait, is this XP or is this Windows 7? I can't tell, man. This is definitely XP. This is not on olive green. That's probably the issue, yeah. So that kind of thing is why, SuperPi 32M on locked, cheap, old, slow CPUs is kind of a popular benchmark because... well, actually, it could be the memory, because that's just, well, I don't know, 2006 10.6 I would have assumed is faster than 2280 811.7. Not sure about that. But then also, like, SuperPi has a bunch of software tweaks that you can do, and so, yeah, and you can also see, like, 3.3 gigahertz almost there, but, way slower than Skull, so... Basically, this becomes sort of a tweak fest of tweak your memory and tweak your OS until you get the best score. And Also, have a lot of patience because the benchmark takes 10 minutes to tell you if what you've done actually made a significant difference. Well, it's not quite that bad, right? Like, you have the different loops. So you can basically go like, well, if by loop 10, I'm not seeing an improvement, what I've done probably just didn't do anything in the first place. Yeah, so a great result from Skull here with the second place, SuperPi 32M score for the Pentium G860. And that is it for this week's HWbot score roundup. So, yeah. Thanks for watching, I guess. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. Both of those help out immensely with running the channel, so it would be much appreciated if you check out the Patreon or the Teespring. And that's it for the video. So thank you for watching, and goodbye.